Right, this is energy problem for a car on a hill. It gives you the location of the hill heights, and it gives you the initial speed of the car. And the question is to find the speed at each one of those positions. What you want to do then is write an energy equation. And let's see, we want to know each position. Well, we already started at A, so A is easy to answer, 12 meters per second. So the B is the first one we have to calculate. From A to B, we can say that we have a certain amount of gravitational potential energy that we're going to increase. So let's draw an energy diagram at position A and an energy diagram at position B. At A, we have kinetic energy. We have gravitational potential energy. At B, we're probably going to have kinetic energy and gravitational potential energy, but we'll find out for sure. We just need to set these two equal to each other. So we have 1/2 mv squared initial plus mgh initial is equal to 1/2 mv squared for the final velocity plus mgh for the final height. Notice on both sides m we can get rid of, which is why the mass of the car wasn't given. But I do have initial height, final height, and I have initial velocity. So the only thing I don't know is that final velocity. Solve for that final velocity. Well, maybe solve for the final velocity squared first. Notice we'll be dividing by 1/2, or I could just multiply by 2. And then I can take the square root, and that'll give me my velocity value. I'm going to write it as 2 times everything in the numerator. And then now I can substitute my numbers. Height at A is 11 meters. And height at B is 19 meters. Put all those numbers in the calculator and we'll get an answer for the first part. Alright, when you put those numbers in the calculator, you notice it gave you a negative square root number, or it could have just said non-real result. What that'll indicate is that you don't have enough kinetic energy to make it to the top of the next hill. In terms of the diagram, what that means is you're going to be rolling until you get partway up the hill, and then you're going to roll back down. So we'll say implies can't reach point B. So then we'll adjust the question. So we'll write a new question here, and we'll say how high can B be? Such that the car just makes it over the hill. In terms of an energy diagram, what that's suggesting to us is that we're going to say that I'm going to say that all of the energy stored at location A is going to be kinetic, and then all of the energy at location B is going to be gravitational. So that would mean you'd be stopped momentarily at the top of the hill. Now to make this assumption, notice back up at the beginning part of the problem, I told you point A is 11 meters above what we're calling the ground. Well, how can I call A zero gravitational potential position? Well, what I'll do is I'll just redefine A as 0. So associated with this diagram right here, I'm saying I'm making A is the new 0 potential. Or in other words, it's the same thing as saying I'm going to write B in terms of A. So write the height of B. Whoops, right. The height well, I could say in terms of, or maybe I should say with respect to that way I can say all kinetic energy at A, all gravitational potential energy at B. Well, that simplifies my life because then I can just say 1/2 mv squared is equal to mgh. Still don't need to know the mass, but what I have now is h is the height difference between A and B. And I can solve for that, so I can say that h then is equal to 1/2 v squared all divided by g. Substitute my numbers, so I have 1/2 of 12 squared divided by gravity. And I can put that in my calculator. Gives me 7. Okay, I don't know why the pen stopped working. Alright, just a minute here. Alright, pins back. 7.39, or I should say 35 meters. What that tells me is that point B can be at most 7.3 meters higher than A. So if A is currently at 11 meters, B maximum is 18.35 meters. And now that's clear to see then why in the first case, notice it told us B was 19 meters. Well, if B is 19 meters, you're never going to get over it. It has to be 18.35 or less. Now, one thing I should have noted back here at the top is we're assuming we're going to not have the car pushing on the ground. So in other words, the car's coasting, it doesn't have an engine. Maybe I better make a little note of that up here. There we go. Alright, we're not going to worry about B, C, D, E, or F then, since we didn't even make it over the first hill. So that'll count as example 1. Alright, why is the pen not working?